Hello and welcome back to another linear algebra video. Today we will be talking about Gauss-Jordan elimination. So this basically stems from our Gaussian elimination, and I think it is much more useful than Gaussian elimination because we do not have to substitute our values back in. And it's very useful for these things called parameters. And we will get to that part very soon. So let's just look at an example. We have this matrix. Must not be the marker I was using. And then we have, okay, so let's use our Gauss-Jordan elimination first. So what our Gauss-Jordan elimination would tell us to do is basically take this, subtract or add to these rows to make these zeros, and then we would use this, add or subtract to this row to get zeros. But in Gaussian elimination, we would be done there. But in Gauss-Jordan elimination, then we want to also use this row to eliminate this, and then we use this number to eliminate this and this. Now, I said that without doing it because in this example, we won't get to do all of this, but you'll get an idea for it. The reason we won't be able to use all of this is because this matrix or system of equations actually has infinitely many solutions. It is just that the solutions, the value of the solutions depend on each other. So let's solve. Let's subtract row 1 from row 2. So we're still going to have the same row. We're going to have 0, we're going to have 0, we're going to have 1, and we're going to have 1. Okay, now let's subtract 2 row 1s from row 3. We're going to get 0, 0, 0, 0. What does this mean? Well, we'll get to that. But now let's use our Gauss-Jordan elimination. We can now use this to get rid of this. So let's subtract row 2 from row 1. So we're going to get 1, 1, 0, 1. And we're going to get 0, 0, 1, 1, 0, 0, 0, 0. So we know the value of, we'll call this x3, the third value. We know the value of x1, but it's only given in terms of x2 and a constant. So what we have to do is introduce these things called parameters, where parameters can go from any value, or maybe we're given a condition where they can only span from certain things. So let's say that x2 equals t. T is our parameter. Well, then x1 plus x2, but that's t now, equals 1. So x1 equals 1 minus t, and x3 actually just equals 1. So our solution is x1 equals 1 minus t, x2 equals t, and x3 equals 1. And so this means there is infinitely many solutions to this matrix. So that brings me to the last point of this video, is that there can be multiple outcomes of Gauss-Jordan elimination. So let's take a look at them. I'm going to erase our solution because we've already gone over this problem. But let's say we have a row of zeros and then some non-zero constant, say 1. Well, we know that 0x1 plus 0x2 plus 0x3 must equal 0. It can't equal 1. But this is telling us that it equals 1. So what's that mean? It means there's no solution. The parameter situation where we had a row of zeros, this is our second outcome. Any time that we have 0 times x1 plus 0 times x2 plus 0 times x3, it's going to equal 0, like we just said. But that means that x1, x2, and x3 can be any value. We don't care. It can be anything. So that means there's infinitely many solutions to this matrix. Lastly, and we've seen this, is when we actually have values for everything. And this means there's one solution. So we have, I guess this would be a 0. We'd probably interchange these rows, but this gives us that x1 equals 1, x2 equals 0, and x3 equals 1. Obviously, there's one solution. We can't change the values or this won't be true. So that's Gauss-Jordan elimination. I hope to see you in the next video where we talk about determinants. And thanks for watching.